Let's go ahead and try an example of compound machine math. So let's look at this example here. If we look at it, we can see very clearly the effort force is applied over here on this movable pulley. And this movable pulley is lifting up this second class lever here. And it's a second class lever because the effort force of the pulley is being applied on the outside of the fulcrum to the FR. So let's write that out. Let's say it's a movable pulley lifting up a second class lever. So the question becomes, what is the total mechanical advantage of our system? Well, if we look, we have two machines. So in the past, we multiplied all the mechanical advantages together. In our previous example, we had three machines working together. This time we only have two. We have a movable pulley lifting up our second class lever. So we have two. So in this case, we would say, well, mechanical advantage 1 multiplied by mechanical advantage 2. We would just multiply all the mechanical advantages together. And again, this is not different than the last example. You might say, well, there were three numbers last time, Mr. Anderson, and you'd be right, but that's because there were three machines. We are going to multiply all machines' mechanical advantage together to get the total mechanical advantage. So the next thing we need to figure out is, what is the total mechanical advantage? Well, or define that out, I'm sorry. The next thing we need to figure out is, what are the individual mechanical advantages? Well, if we look at mechanical advantage of machine 1, well, that's just a movable pulley. That's the IMA of machine 1, which is just 2, because the mechanical advantage of all movable pulleys, or the IMA of all movable pulleys, is 2. So we're good there. We move on, we say, well, what's the mechanical advantage of machine 2? Well, we aren't given much about it except for two distances. So we can say, well, that's IMA of machine 2 is DE of machine 2 divided by DR of machine 2. Well, how do we figure out which one is DE and DR? We're given two distances, but we aren't given much else. It doesn't tell us which one is DE and DR. Well, we can look at it a couple different ways. One way to look at it is, well, dr is the distance to the force resistance. Well, the force resistance is right here. That is the distance from the fulcrum, so that's the number that goes on bottom is 4 feet. So we put 4 feet on bottom. And that means the other number on top has to be 12 feet. It has to be the distance effort. And if you look at it, that kind of makes sense that that would be 12 feet because that's the distance from the fulcrum to our effort force being applied through the movable pulley. Well, that's just 12 feet divided by 4 feet, which gives you a mechanical advantage of 3. So we can say this equals 2 times 3 because that's what the two mechanical advantages equal. So we multiply those together and we get a total mechanical advantage of 2 times 3 is 6. And that's all you really have to do to solve for total mechanical advantage. It's nothing new, nothing different. But we could take this problem one step further. What if I told you that this FR right here, this FR was, I don't know, let's say it's 250 pounds. So 250 pounds. I could say, what does FE equal? What effort force would I need to lift up this 250 pounds using this compound machine? Well, you'd have to ask yourself, what do you know? Well, we know the FR of this, the total FR, I'm sorry, FR total, we just said, is 250 pounds in this example. Okay, let's go ahead and write that out a little bit better so it doesn't look like 2501. 250 pounds. We don't know FE, but we do know the total mechanical advantage. So that means the actual mechanical advantage total is 6. So we use our equation for actual mechanical advantage. We get actual mechanical advantage equals FR over FE. Well, we know those numbers. We could take this equation one step further and plug them in. We could say, well, AMA is 6 equals FR, we just said, is 250 divided by FE, which we do not know. And from there, we can just do simple algebra to find effort force. Or we could do my favorite trick for these kinds of questions and just put 6 over 1, because that won't change what this is. And from there, we can cross multiply and divide. We can say 1 times 250 or divided by, let's go ahead and put 1 over here, divided by 6. And we'll pull up our handy-dandy calculator to figure that out. 1 times 250 is just 250. So 250 divided by 6, well, that would give us an effort force of about 41 2/3. Or 41.67 equals total FE.